Section 5.4 is all about applying trig functions. So we're going to take those sine, cosine, and tangent mainly. We won't really touch the other three for now. And we're going to use those to help us solve for angles and sides and triangles and apply them to real life scenarios as well. The main thing that we need to go ahead and start off with is the understanding that our calculators need to be in degree mode. If they are not in degree mode, you need to put them that way. They always default back to radian mode, so it's important that, especially if somebody clears the calculator before you, you go ahead and check it and make sure that it is in degrees. So if you hit the mode button right next to the second button, you need to make sure that degree is highlighted before you continue. Otherwise, all of your measurements are going to be a little bit crazy. So we're going to jump right in. The first types of examples that you're going to do is if I give you some sort of triangle scenario and I give you some information about it and ask you to solve for missing sides or angles. So if I have triangle ABC, and consequently in geometry, if the angles are capital ABC, the opposite sides are lowercase ABC. So if they give us a problem and they say, okay, B is 62 degrees and C is, little c is 24, what if the question is to find little b? I'll write it over here. Find little b. So let's go ahead and label our triangle with what we know. We know that angle B is 62 degrees, and we know that side C is 24 degrees, the hypotenuse is 24. So if we want to find angle B, I like to, and I'm going to show you how to do this basically, essentially foolproof, but once you get the hang of it, you're not necessarily going to need to do this each time. In order for you to set up a trig ratio, you first need to identify, okay, what is your reference angle going to be? Well, I'm going to choose this 62 degree angle just because it's here. If you want, you can solve for angle A and use that as your reference angle, but the important thing to remember is you can never use the 90 degree as a reference angle. Then from that reference angle, I'm going to ask myself, okay, what information do I have? Well, I have the 24, the length of 24, which stands for the hypotenuse of the triangle, and I'm trying to solve for B. So side B is opposite of angle 62. So once I write out this information, then I ask myself, using SOHCAHTOA, which one of those has hypotenuse and the opposite for its comparison? So obviously it's going to be sine. So then we're going to go ahead and set up our trig ratio. It's going to say the sine of 62, sine of the angle, is equal to opposite over hypotenuse. So the opposite side was B, over the hypotenuse is 24. So all we've done so far is just set up the ratio. From here, we want to actually go ahead and solve for B. So if I want to isolate the variable B, then I want to get rid of everything else. So the opposite of dividing by 24 is multiplying by 24. And what I do to one side, I need to do to the other side as well. So therefore, B is going to equal 24 times the sine of 62. And you're going to plug that into your calculator exactly as you see it. For the sake of consistency in this video, we're going to round everything to the nearest tenth, and you will get decimals many times. So to the nearest tenth, you should end up with B as approximately 21.2 when you plug that in your calculator. So there's one example. Another example will be something similar. We're going to use the same triangle setup, ABC, except I'm going to give you some different information. So if I tell you that A is 17.3 and B is 77 degrees, find side C. So again, let's label our triangle with our given information. So side A is 17.3. B is 77 degrees. So that's this one here. And this time it wants me to find side C, which is here. So I'm going to put an X there. So we're going to continue just like we did with the last problem. I'm going to write out my list of information. Again, every time you must have a reference angle. So here I'm going to choose the 77 degrees. And then I'm going to ask myself, okay, from that 77 degree angle, what kind of information do I know? Well, I know that from that 77 degree angle, that 17.3 is adjacent to that. And I'm trying to find side C, or you can call it X or whatever you want, which is going to be the hypotenuse. So then if I look at this list here, I've got adjacent and I've got hypotenuse, which means that we're going to use the cosine ratio. So if we set up the cosine ratio, that looks like the cosine of 77 degrees equals adjacent over hypotenuse. So that's 17.3 over C. So the goal is the same as it was earlier. We still want to isolate the variable, but this time it's a little bit different. You could, if you want, multiply both sides by C and then proceed that way. Or some of you might benefit from envisioning this problem as a proportion. If you put the left side over 1, that allows us to cross-multiply, which is essentially what you'd be doing if you multiplied both sides by C anyway. But if you just think about it this way, then you end up with the cosine of 77 times C equals 1 times 17.3, which is just 17.3. And then to get C alone, right now it's being multiplied by the cosine of 77. So if I want to undo that, I'm going to divide both sides by the cosine of 77. And this is what you're going to plug into your calculator, 17.3 divided by the cosine of 77 degrees. And when you do that, you should get that C is approximately 76.9. So that's how you solve for missing sides in a triangle given some information. We're also going to use these trig functions very frequently in word problems. And in those, you're a lot of times going to see the words elevation and depression. When you think of the word elevate, I need you to think of the phrase going up. And when you think of the word depression, much like we use it in everyday language, I want you to think of the term as falling down. So in a right triangle, angles of elevation would be like this angle theta here, or if the triangle were flipped the other way, it'd be this angle here. It starts at the bottom and it's looking up. Those are angles of elevation. Angles of depression are obviously going to start up at the top. We'll call those alpha. And they start up at the top and they are falling down. In this problem here, it gives us a scenario where an escalator has a vertical rise of 195.8 feet. And it says if the angle of elevation is 10 degrees, 21 minutes, 36 seconds, find the length of the escalator. In all these questions, guys, I highly recommend you just drawing a picture that labels or that represents this scenario. So if I've got an escalator, for the most part, you can count on these always being right triangles, so don't hesitate to start off the drawing that way. So it says the escalator has a vertical rise that tells you to go ahead and label this side 195.8 feet. The angle of elevation, again, referring back to our stuff up at the top, angles of elevation start off on the bottom. So if this is 10 degrees, 21 minutes, and 36 seconds. The question is, find the length of the escalator. So we call that L, or you can call it X or C since it's the hypotenuse, whatever you want. And we're going to treat this problem just like we did the others. We're going to write our reference angle and what we have and what we know need to find out. The first thing I would do before I even list that information, though, is convert this strictly to degrees. So again, in your calculator, if you actually typed in 10 degrees, 21 minutes and 36 seconds and you hit enter, you should end up with this is equal to 10.36 degrees. So that's what we're going to refer to this angle as now, 10.36 degrees. So let's list out our information. if we have a reference angle as 10.36 degrees, we want to list what other stuff we know. Well, from that angle, I have a 195.8 length opposite of that. And I'm trying to find L, which is the hypotenuse of the triangle. So again, if I look at this list and I compare it to SOHCAHTOA, I have opposite and hypotenuse, which tells me that I want to go ahead and use the sine function. So if I set up the sine of 10.36 is equal to opposite over hypotenuse, so it's going to be 195.8 over L. All we need to do to solve for the length of the escalator is to solve for L. So we're going to use some algebra to isolate L. You can take the approach that we did in the last problem, where you can just put the left side over 1 and then consider this a cross multiplication. So then we can say that the sine of 10.36 times L is equal to 1 times 195.8. And then to isolate L, right now it's being multiplied by the sine of 10.36. So we want to go ahead and divide both sides by the sine of 10.36. So if you plug this in your calculator, 195.8 divided by the sine of 10.36, you should end up with the length of the escalator, again rounded to the nearest tenth, being approximately 1,088.8 feet. And those are, you'll have plenty other real life scenarios with that vocabulary of using angles of depression and elevation to solve for missing sides and angles. Section 5.5 focuses on solving right triangles. Now, we were just doing that. The only difference between pretty much 5.4 and 5.5 is 5.4 focuses on solving strictly for different side lengths, whereas 5.5 also incorporates how can we solve now for the angles of a right triangle, given some information, not just the sides. So examples that you're going to see, first of all, with that in triangle, if we bring in the unit circle, you might get something that says to solve for each if 0 is less than or equal to x is less than or equal to 360. So I want my angle to be on the unit circle between 0 and 360 degrees. So the first one might be if we have that the sine of x is equal to the square root of 3 over 2. So I want you to think about what this means for a minute. The sine of some angle is equal to the square root of 3 over 2. Now, if you recall what we learned with the unit circle, we said that the sine of something, the sine of any angle theta, was actually its y coordinate. So we have to think about, okay, which angle, or angles, because it might be plural, have the square root of 3 over 2 as its y coordinate. And for that, that's where your knowledge of the unit circle is going to come into play. If you actually look at your unit circle, and I don't have my plate readily available here, but hopefully you're looking at your unit circle, and you compare, you just basically look for whatever one of those angle marks has the square root of 3 over 2 as the y coordinate, you should see that in two places. You're going to see that at the 60-degree angle and the 120-degree angle. So that knowledge is strictly from the unit circle. Those coordinates at those degrees will have y values of the square root of 3 over 2. Another one, what if I ask you for the cosine of x is equal to this negative square root of 2 over 2? So again, let's think about what we learned. We said, well, the cosine of any angle theta was essentially its x-coordinate. So you're asking yourself, okay, which angle or angles on that unit circle have negative square root of 2 over 2 as the x-coordinate? And that negative is important because that means you cannot use the positive ones. So that's going to be to the left of the y-axis. You should see two angles that have negative square root of 2 over 2 as the x-coordinates, one of them being 135 degrees and the other being 225 degrees. So I know I'm not referencing the unit circle here in the screen. If you're still struggling with where that is and you're not looking at your circle, then that's going to explain it. Otherwise, even if you're looking at your circle, if you're not too sure where and how you should be looking, make sure you ask this question in class when we review this video. So this next part talks about what happens when we know the sides of a right triangle, but we need to solve for the angle. So for instance, if I have something like the sine of theta is equal to 3 over 5. So in all those other questions, we had things like, okay, well, the sine of 64 degrees is equal to x over 310, and then to solve for x, you just multiplied both sides by 310. Well, we're doing the same thing, except our variable now is theta, and we still want to try to isolate theta. But you can't okay, let me subtract the sine from both sides, because you're like, well, what is that? What does that even mean? So you need to basically undo sine. Well, just like regular functions, so or regular operations, right? Addition and subtraction are inverses. Multiplication and division are inverses. Your trig functions have inverses as well, and those are literally called sine inverse, cosine inverse, tangent inverse. So we need to undo, very, very, very informal. Writing the word undo, but that's kind of what explains it well. So we need to undo sine in order to isolate theta. To do that, we are going to use literally inverse sine, or sine inverse. I really don't care what one you say it in as. So sine inverse looks like this. It looks like sine to the little negative first power, which you probably are very familiar with seeing that on your calculator. It's above literally the sine button. Sine inverse is the same exact thing. Sometimes you might see this as arc sine. So sine inverse and arc sine mean the exact same thing. They are simply the inverse functions of sine. And they're not just for sine. We also have cosine inverse and arc cosine. We also have tangent inverse and arc tangent. So this does not just apply to sine, it applies to all three of them. So in this case, if I want to undo sine and I want to isolate theta to get it by itself, I want you to think about taking the sine inverse of both sides. Okay? Well, if I take the sine inverse of sine, I'm basically undoing it. So that's going to leave me just with theta on the left side. And that means on the right side, when I take, so here's what it looks like. If I take sine inverse of this side and sine inverse of this side. Well, the sine inverse of sine, those guys cancel out because those are inverse operations, just leaving us with theta. And then on the right-hand side, theta is going to equal to sine inverse of 3/5. So if I want to calculate that angle theta, all I need to do is compute this. And again, you might see this the same thing as theta is equal to arc sine of 3/5. But on your calculator, you're going to see this function here. So what you're going to do is you need to make sure you hit second sine and then type in 3 over 5. Again, if you check that to make sure that you were in degree mode, when you do second sine of 3/5 or sine inverse of 3/5, you should end up with theta is approximately 36.9 degrees. So that means the angle that has the 36.9 degree angle has an opposite side ratio to the hypotenuse side ratio of 3 to 5. So taking what we just did one step further, sometimes I'm going to ask you to evaluate a trig expression, but I want your answer as an exact value. So in other words, you're not going to plug the numbers into your calculator using the inverse, sine, cosine, and tangent. And rounding, you're going to use what you know about the unit circle and about the inverse trig functions to evaluate these. So the first one, I want you to go ahead and evaluate the tangent of tangent inverse of 6 over 11. The tangent of the tangent inverse, or inverse tangent, of 6 over 11. Well, this looks kind of like a hot mess, but it's actually really easy. The tangent of tangent inverse, these guys are inverses of each other, which means they're going to cancel each other out. So if they cancel each other out, that means the tangent of the tangent inverse of 6/11 is literally just 6/11. So that's like me taking the number 5 and multiplying it by 2 and dividing by 2 in the same problem. Those cancel and I'm left with my original number anyway. Okay. Now, some are not that easy. So you're also going to get some where you have to do a little bit extra work to it. So if I ask you for the cosine of arc sine of 2/3. So remember, arc sine is literally the same thing as the inverse sine of 2/3 if you prefer to see it or say it that way. So what I want you to do is I want you to think about this and say, okay, let's call this guy the cosine of, remember, this is an angle, right? So if we have the cosine and we take the trig functions of angles, let's just call this theta for the time being. If we can solve for theta, then we can solve for the cosine of theta of whatever that angle might be. So let's deal with this part first. Let's cover up this cosine and just deal with this part. That means we can say that theta is equal to the arc sine of 2/3. Okay, so that means if, again, we want to kind of backtrack here, and I want to undo arc sine, that means I'm going to take the sine of both sides, because that's the opposite. So if I take the sine of this side and the sine of this side, and that means on the left side, I'm left with the sine of theta is equal to, on the right-hand side, the sine of the arc sine, or inverses, so those cancel, and all I'm left with is 2/3. What this allows me to do, remember, I'm not really trying to isolate theta like we did in the problems previous to this slide, because that doesn't really help us. We're trying to define theta to be able to draw a triangle. Once you get to this point, if you know that the sine of theta is 2/3, well, then you're very capable of drawing what that scenario should look like. So if I have a right triangle and I label any of those angles theta, sine is opposite over hypotenuse. So that means the opposite of theta is 2. The hypotenuse must be 3. If I can solve for the adjacent side, then I can figure out what the cosine of that angle theta should be. So let's do that. If I do Pythagorean theorem, it's going to be, let's just call this x for now. So if I have x squared plus 2x, x squared plus 2 squared equals 3 squared, then I'm going to get x squared equals, so it's going to be 9 minus 4, which is 5. So then I get that x is equal to the square root of 5. Remember, I disregard the negative one. So down here, I have that is the square root of 5. So let's look at what we've done so far. If the sine of theta is equal to 2/3, then that means I can find the cosine of theta, what I just drew from this triangle here. So cosine is found by comparing. So now we're going to rewrite this to be the cosine of theta, which compares adjacent over hypotenuse. So adjacent from theta is the square root of 5. The hypotenuse is 3. So this one's kind of like a puzzle. The first one was very, very simple. The inverses cancel each other out. The second one was a little bit of a puzzle. You need to work from the inside out, first by drawing a triangle that represents that scenario, and then doing the outside function ratio based on what you found from the inside function. The last thing we're going to discuss is how to solve for angles in that right triangle, given some other information. So in this example here, I've got two sides of my right triangle. The question is to find angle N, capital N. We know that that's going to stand for angle N. So the first thing I'm going to do is I'm going to put theta where angle N is, just to kind of help me visualize my point of reference. And then I'm going to do what we've done for all of those other examples where we're solving for stuff in a right triangle. I'm going to list my information. I'm going to say, okay, I've got a reference angle of theta. I don't know what that is yet. And then from theta, from that point of reference, I know two things. I know that 18.8 is opposite, and I know that 14.3 is adjacent. And then if I use my SOHCAHTOA mnemonic, I realize I should be using the tangent ratio because that one has opposite over adjacent. So then if I set that up, the tangent of theta is equal to opposite over adjacent will be 18.8 over 14.3. Well, in the other problems, we'd cross multiply or we'd multiply both sides by something. But remember here, if I'm trying to isolate theta, I need to get theta outside of tangent. To do that, I need to do the inverse of tangent, which is literally tangent inverse. So if I take the tangent inverse of both sides, remember, tangent inverse of tangent cancels because those are opposites. So we're literally just left with theta. And then on the right side, we're left with the tangent inverse of 18.8 over 14.3. And then if you type that into your calculator, if you hit second tangent, make sure you do second tangent because it'll bring up the inverse of 18.8 over 14.3. You should end up with theta is approximately 52.7 degrees, or angle N, rather, is about 52.7 degrees. So that's just solving for one angle. Some of the other examples you're going to get are just going to ask you to solve the triangle completely, which means they're going to give you some information about the triangle, and by the end of it, between what they give you and what you find, you need to have answers for all three sides and all three angles of the triangle. So if they give us this triangle here, let's call it ABC. And let's call this side 12.5, and this is A, and this is little c, and this is 47 degrees. So that basically means everywhere there's not an angle measure marked, I need to find that, and everywhere there's not a side measure, I need to find that as well. The deal with these questions is that you can take many approaches, and there are lots of different ways to solve it, and lots of different orders in which to solve the sides and the angles. I personally, if I see something like this, realize that my angles are going to be really easy. If this is a 90-degree angle and this is a 47-degree angle, and I recall that every triangle must have the three angles that add up to 180 degrees, I'm just going to go ahead and solve for angle A off the bat and say, okay, well, 180 minus 90 minus 47 gives me angle A, which is going to be 43 degrees. So there's one of my answers off the bat. That solves for the third angle. Now I need to solve for side A and side C. And here you have a plethora of information. So you can choose whatever the heck that you want to choose. I'm going to choose the reference angle to be 47. Why? Just because I like 47. If you want to use this 43-degree angle as your angle of reference, that's fine too. So my reference angle is being 47 degrees. From this angle, I know 12.5, which is opposites, and I need two things, so just pick one of the things that you need for now. I'm going to go ahead and choose A. Well, A from this angle is going to be adjacent. So if I have opposite and adjacent, that tells me I want to go ahead and use tangent, so that the tangent of 47 degrees is equal to opposite over adjacent, so 12.5 over A. And then to solve for A, again, you can do this in lots of different ways. If you put the left side over 1 and cross multiply, you end up with the tangent of 47 times A equals 12.5. And then to isolate A, we're going to go ahead and divide both sides by the tangent of 47. And when you divide 12.5 divided by the tangent of 47, you should end up with the answer for A, which again we're going to be rounding to the nearest tenth, is 11.7. So there's another value for A. So let's write what we know. We know this side's 11.7. We know this angle is 43 degrees. The last thing we need to do is solve for side C. You have multiple options. You can use trig again, but if you're more comfortable with the Pythagorean theorem, then look what you've got. You've got the two leg lengths, and all you need to do is find the hypotenuse. So just use Pythagorean theorem if you'd like. If I go ahead and take 12.5 squared plus 11.7 squared is equal to C squared. When I add all that together, I get 293.14 equals C squared. And then when I take the square root of both sides, rounding to the nearest tenth, I get C is approximately 17.1. So notice in the end, they started me off with one side and two angles, and by the end I have the other three components to solve for that right triangle. So this video was a little bit longer because we squished two sections together. I typically won't do that, but for the sake of time I needed to do so. So your assignment's going to come from two separate sections. The first one being on page 302. There are just 6 short questions from that. The second being from section 5.5 from textbook page 309, and there are 12 problems from that section. So this homework assignment is going to have 18 problems total that you will need to complete and turn into Mr. Ware no later than this Friday.